Okay, we're going to go to page 10. Everybody, page 10. So today we are going to do reduced row echelon form. That's RREF. RREF is actually the preferred way. And so what's going to happen is your reduced row echelon form will look like this. 1, 0, 0 number, 0, 1, 0 number, 0, 0, 1 number. So recall, this means X, this means Y, this means Z, and this is the constant. That line means equal sign. So then when you get to this form, it's actually really, really nice because it just tells you that X is equal to A, Y is equal to B, and then Z is equal to C. So you do want to get it to this form. Since we have so much trouble with the hand calculating version, let's start with calculator first so you can kind of feel better about these numbers. And then we'll go in and do the hand version. All right, so this question says solve this system of three equations by matrix. We're going to use the calculator first. So that means you need to put that in the calculator. What size of a matrix are you going to put in? 3 by 4. So this time you're going to go to RREF instead of REF. Okay, once you do RREF, you should get 1, 0, 0, 2, 0, 1, 0, negative 1, 0, 0, 1, 3. Yes? No? You got this, right? Okay, so then X is 2, Y is negative 1, and Z is 3. Okay, the hard part. We're going to do this by hand. So remember, we need to get it to look like this so that we can get 2, negative 1, and 3 from the answer. So first thing, 1. Okay, we do have that 1. We're going to go down. So there, for me, there is a system which I do this. So I always get the 1. And then I go down and I make it 0. And then I make this next one 1. And then I make the other ones 0. And then I go to this one. And then I make the other ones 0. If I don't do it in this way, I sometimes have to go back and then fix my mistakes. So that's just better if you do it systematically. All right, so that first one, 811, that is good. So we're now going to make 3 equal to 1. So how do we do that? Huh? How do we get this 3 to become a 0? Okay, multiply first row by negative 3. And then? Add 2. And then replace the row 2, yes. All right, so that is negative 3, 6, negative 3, negative 21. Add to row 2, 3, negative 5, 1, 14. That becomes 0, 1, negative 2, negative 7. We're going to replace row 2. 1, negative 2, 1, 7. 0, 1, negative 2, negative 7, 2, negative 2, negative 1, 3. Okay, so people who didn't learn this last year, are you with me? Like, you know what to do now? Yes? All right, the next thing we're going to do is we need to make this 2 equal to a 0. What should we do? Yes. Okay, so negative 2, 4, negative 2, negative 14, 2, negative 2, negative 1, 3, 0, 2, negative 3, negative 11. 1, negative 2, 1, 7, 0, 1, negative 2, negative 7, and then 0, 2, negative 3, negative 11. Okay, what should we do next? We usually go to this one and make that a 1, but that's already a 1. Okay, how do you want to do that?
Times 2 to the second row minus.
Okay, so I like to multiply negative numbers because when we subtract, there is always a chance for mistake. Adding is less likely to make mistakes. Okay, let's have you guys finish. I think you can.
But like the top, like how do you finish to make it 0?
So the key is, yeah, so the key is you always want to just use whatever you made into a 1 to cancel the other ones. Does that make sense? You always want, so whatever you want to make into 0, you always use the row that has the 1 and then add them. That's going to make them a 0. Mark? Okay. Huh?
I don't know how to explain what my situation.
Okay, all right, I'll come over and help. Okay, so this one, the first one you were doing, let me see what the answer was. It was 2, negative 1, 3. And then if you finish this one and you went to this next one, this answer is 2, negative 1, 4. All right, you're going to do a lot of this for homework, so we're not going to practice by hand anymore. We're going to do this one. This one's a little bit interesting. You're going to solve it by calculator, and your answer is going to be strange. So we have to be able to interpret what our answers mean. Okay, so go ahead and solve it with calculator. Okay, your answer should be something like 1, 0, 3, 5, 0, 1, negative 2, negative 2, and then 0, 0, 0, 0. Right? Okay, well, what does the solution mean when one of them is all 0? Not no solution. Infinitely many solutions. Because what happens is you have 3 variables, you need 3 equations to solve. However, if you solved it and then one of them goes away, that means you really only had 2 equations to begin with. So 2 equations cannot solve 3 variables, so this is infinitely many solutions. However, we can still write our answers in some form. So let's go ahead and write these 2 available equations back into their equation form. So this means x plus 3z equals 5, and then y minus 2z equals negative 2. So if we had to write 3 variables for our answers, since it's infinitely many solutions, they're all just going to be kind of in proportion with one another. So let's say that we want to solve in terms of z, meaning z is my variable, that variable is set, and then everything else is in terms of z. Then what I can do is solve x in terms of z. So x is equal to 5 minus 3z. Y is equal to negative 2 plus 2z. And z is z. Does that make sense? By the lack of replies, I'm going to guess it does not make sense. So 5 minus 3z, negative 2 plus 2z, and z. So it just means whatever this is, as long as you select a z, you can find x and y. So this is infinitely many solution because it could be anything you want, but it has to have that kind of relationship with each other. Does that make sense? Yes?
How do you know you solve in terms of z?
You don't have to. You can solve it in terms of other things if you want. X but it's just that there was z common in both equations, so it's just easier to do that. Okay, so let's have you guys try one more, and then we will go on to the other stuff. Okay, so let's have you guys try this one. X, Y, Z, W. Let's have you do it this way. X, Y, Z, W. That way we're all talking about the same thing in that order instead of W, X, Y, Z. Right, usually we do W, X, Y, Z, but I don't know why they put W as the last one. So if we can all just do X, Y, Z, W, then we will all look at the same matrix. Okay, so this one is missing a few variables. So in terms of W and Z. Okay, so I think you would have the answer like this: 1, 0, 1, 2, 1, 0, 1, negative 2, negative 1, negative 1, and then 0, 0, 0, 0, 0. So actually you only have two equations, but 4 unknowns. You didn't get that? You didn't? Okay, what is the size of your matrix? 3 by 5. Okay, 1, 2, minus 3, no. 0, okay, negative 1. 2, 3, minus 4, 1, negative 1. 3, 5, negative 7, 1, negative 2. I still get the same thing. Okay. Those of you who didn't get the same, you might have to check your matrix. Double check, make sure it's right. So this means X plus Z plus 2W is 1. And then Y minus 2Z minus W is negative 1. So since we have only two equations, that means we gotta let two variables be by themselves. So let's make W and Z the independent ones. So then X is depending on W and Z. That's gonna be 1 minus Z minus 2W. And then this is Y equals minus 1 plus 2Z plus W. So this is gonna be 1 minus Z minus 2W, comma, negative 1 plus 2Z plus W, comma, Z, comma, W. You guys look very tired. We don't have time to go over the inverse matrix part. So I'm gonna put that as part of your video that you had to watch for. But it's not that hard, I think. It's basically the same as last year. That does not help very much. Anyways, that's.
I don't remember.